cicd, continuous integration and continuous delivery, getting your code to production faster while reducing risk. You push a commit, your code gets automatically tested, a new package is built, and the new version of your app is live for users in minutes. But here is the part most engineers miss. CI/CD doesn't automatically guarantee safe releases. It actually makes failures happen faster. So in this video you will learn what a pipeline is supposed to do and how to make it work the right way. Why manual releases break even when the team is careful, continuous integration versus continuous delivery or deployment. Without the confusion, some of the zero downtime strategies like blue-green, canary, and rolling deployments, and how tools like GitHub Actions, GitLab CI/CD, and Jenkins are used in the workflow. My name is Diego, I'm a network and systems engineer based in Paris, and I like breaking down tech concepts into simple and visual explanations. If you want to see more videos like this one, feel free to subscribe, and that's all. Back to the video. Here is what usually happens in real teams. A feature is finished and the release day feels stressful. One person follows a document, another one updates configuration values, and another one restarts the application. And most of the time it works, until one day it doesn't. Manual releases fail for two main reasons. First, humans. We are not perfectly consistent. Even a small forgotten step can break everything. Second, deploying feels expensive and risky, so teams avoid doing it often. The problem with not deploying often is that code changes and features become larger, and larger releases mean more risk. CI/CD changes the game by turning releases into a clear step-by-step pipeline, with safety checks instead of a deploy and hope process. Let's keep one mental model in our head. CI/CD is a production line, where every station is a safety gate. Code enters on the left, users are on the right. Everything in the middle is there for one reason: to reduce risk while increasing speed. These production lines, usually called pipelines, are created using tools like GitHub Actions, Jenkins, or GitLab CI/CD. It really depends on the company. Now let's split that into two sections: continuous integration and continuous delivery. CI starts with a problem. Multiple developers push changes, and the codebase becomes a risky mess. It works on your machine, but fails when it gets merged into the main branch. So CI introduces the first safety checkpoints, the integration gates. Gate 1. Can we even compile this version? In this gate, we use tools like npm, pip, or maven, based on what you are building. Gate 2. Automated tests. Did we break any existing functionality? This could be automated tests like JUnit, PyTest, or Jest. Gate 3. Quality and security checks. Are we pushing security risks to production? For this gate, you often use tools like SonarQube to check code quality and Snyk to find security vulnerabilities. And here is the key idea. CI is not about deploying. It's about catching problems as fast as possible so that the team can keep building with confidence. Once that foundation is solid, we are ready to talk about delivery. Continuous delivery starts with a simple but important idea. Just because your code passed all the CI checks doesn't mean it is safe to put it into production. For example, your tests run in a controlled environment. Production is different. It has real users, real traffic, real data, and unexpected situations. So continuous delivery adds another layer of safety checks: the release gates. The goal of continuous delivery is simple: being able to deploy your latest version at any moment. But with that, there is also one big reality. The faster you deploy, the faster you can also deploy a bug to production. So continuous delivery needs 3 extra protection gates. First, controlled rollout. You don't release to all your users at once. Second, fast rollback. If something goes wrong, you can quickly go back to the previous version. Third, observability is the decision point. You don't continue the rollout to more users unless metrics like error rate and latency look healthy. These protections are implemented through deployment systems that manage rollouts, monitor health, and automate rollback decisions. For example, tools like Flagger, Octopus Deploy, or Argo Rollouts manage rollout strategies and can automate progressive deployments and rollbacks. These tools don't reduce risk by themselves. They help us to do that by controlling how the new version reaches our users. And that how is defined by your deployment strategy. There are 3 common deployment strategies, and each one solves a different type of risk. First, rolling deployment. You update servers little by little. This is great because your system stays online while you update it. But you need to be careful to avoid issues for users while both versions are running at the same time. 2. Blue-green deployment. Keep 2 identical production environments. This is powerful because you can switch from the old version to the new one instantly. But it's much more expensive since you need 2 full environments. And things like databases can still be complex to manage. 3. Canary deployment. Release the new version to a small group of users first. This one is great because if something breaks, only a small number of users are affected at the beginning. But you must have good monitoring, because if you don't notice performance problems or errors, you can end up releasing a bad version to everyone. Each strategy is just a different way to reduce risk at the end of the pipeline. Let's simulate how an incident could happen while using our cicd pipeline. A developer pushes a change that will accidentally increase the database load. The error is more at the design level, not really at the code level. Because of this, all the CI checks are going to pass. Build pass, test pass, security and quality pass. So this design implementation issue will arrive to our continuous delivery side. And here is what's going to happen. Step 1. We have chosen our strategy, a canary deployment to 5% of users. We don't need to release to everyone immediately. We only send 5% of traffic to the new version. Maybe because we assume something could still be wrong, even if all the CI tests were okay. Observability becomes a safety gate. Don't forget that we are monitoring things like error rate and latency. Suddenly, the latency increases, but only for the 5% of users who are using the new version. That's a red flag. We stop the rollout immediately. Fast rollback. Thanks to our cicd implementation, we can quickly redirect the traffic back to the stable version. And most of the users never notice that anything happened. And that's the key lesson. Continuous integration catches code-level problems, while continuous delivery catches real-world release problems. They are on the same pipeline, but they have different safety gates and different types of risk. If this video helped you to understand cicd better, give me some feedback in the comments, I will appreciate it. In this other video, I explain different tools that DevOps engineers use, including cicd, so see you there.